Okay, so in that test you just saw how many milliamps that the one side of our coil is putting out. A little over 400. As we put a higher load on that, it's going to increase the amount of amperage draw that's coming out of that. Now, everyone's seen me use one of these motors. You saw me make it on the coil winder. So we know exactly what it's going to take to power this. It takes about an amp and it takes 12 volts. So we know that we're putting out more than 12 volts here at our post. So we're going to do a DC load test now. And there's a couple ways you can do that. You can hook a battery up and see how much it's going to draw, but the battery will only draw what it needs. So a running load is actually what I am testing. It's actual functional running load. You can charge a battery with solar panels, but you really can't run a load off of a solar panel unless it's rated at the millivolts that the solar panel is producing. And then you run the risk of shorting out your solar panel depending on if it has a peak draw, which is going to draw more power out of the solar panels than what they're capable of producing. So with this regulator, with this rectifier is rated at 200 volts and 4 amps, which is well under what our load here is going to be. Now, if I flip this around, you'll remember how I cut this wire. These two wires here are for the internal switch, okay? And these two wires here are our power. So what I'm going to do is get this all wired up, and how I'm going to do that is I'm just going to transfer these two contacts out of our AC into our DC, and then I'll connect one side of our wire, which will be our negative side, to the screw block, and then our hot side is going to go through our meter, which will show our amps. Okay, so what we have is I've transferred our wires from our block here, from our AC to our DC, and that's connected our negative side to our black and our positive side to our red. And then our wires coming out of our amperage meter are running here, which is completing our circuit. Now when the amperage meter is turned on, then it will turn on our full system. So that's how that's going to work, and that's powering our motor. And what I have here is just a rag that I have folded up. There's nothing special to it. I'm just going to stick it underneath the motor so that the vibrations don't scuff the paint. But that's why you'll see this sitting up underneath the motor. And so that'll be there. And then we'll go ahead and spin it up and we'll do some voltage tests. So we'll see what the voltage is coming off of it and also the amp draw of our motor. Okay, so what we're going to test here is the amp draw off of this motor. Now remember that these two wires here are just what's going into the electronic switches. This is our other power wire. When I connect these, you'll see that it's drawing almost an amp of power. It's kind of hard to see it rotating. I'm not sure if you can see that or not. But it drops us down, so it's sucking pretty much all the voltage that we're able to put out. And it's drawing almost an amp of power right now. So we know that our coil at 140 feet is producing almost an amp for this particular motor. We are running at 3,000 RPMs. If I disconnect the motor, you'll see all of our voltages come back up. Now remember, because we're DC, we're going to be running a little bit less than AC. Okay, so in our next test, I'm going to charge up this cap here. I've seen a lot of people charge up caps and things on there. It's a 220 UF 400 volt cap. So I'm going to go ahead and charge that up, and I will show you on the meters what we're doing as far as our charge and all of that. Let me go ahead and turn this one off because that was our AC reading. So we have our DC reading here and we have our AC reading here. And I'll go ahead and start this back up. So we have our two contacts. So our negative wire is the clean wire, and our negative is the one with the line. So we'll connect our positive to positive and our negative to negative, and you'll watch it immediately start drawing. our voltage drop a little bit as it starts to draw that voltage off. Okay, so it's about 300 milliamps coming off of that one side of our coil. And that's our large wire. And that's still being filled here, as you can see. I'm just holding it here. I have my hands out of the way so that you can see the meter. If I take this off, you'll see it there. And it will keep climbing. It'll get up to all the way to an amp. I've let it climb all the way to an amp before. And that's about where we're going to stop there. Okay. I'm going to flip this off. Okay, so you've seen the cap get charged. Now what I want to show you is just its discharge, to show you that it is charged. So we'll just discharge it. You can see there was quite a spark. There's quite a lot of power that was stored in this just in a short period of time that we were running it. So far these tests are coming out all really good. We know that we're able to produce almost an amp with this coil. And we know that we're able to produce around 18 volts. So 18 volts and 1 amp is what this coil is capable of producing on the DC side. On the AC side, I'm going to show you a little bit different way to hook up a coil so that you can get some different power readings out of it as well, and show you how to force the coil to operate in a different condition to produce more amps and more volts.